Hello, this is Jake Hans at my system for balancing chemical reactions. So our first step is to identify the reactants. Here we have an example. So the reactants are what goes into the reaction. So aluminum bromide reacts with potassium sulfate. So the reaction is with aluminum bromide and potassium sulfate. So when I say identify, what we basically mean is figure out what this is. So aluminum bromide is an ionic bond between aluminum, which has a charge of +3, and bromide, which has a charge of -1. So because of this, we're going to have 3 bromides in order to cancel out the 1 aluminum. So here. So there's our first reactant. Reacts with potassium sulfate. So potassium has a charge of +1. Sulfate has a charge of -2. So potassium +1. Sulfate -2. So same situation. We need to have 2 potassiums to cancel out the sulfate. So and then we've finished identifying our reactants. Now we need to identify our products in step 2. So to produce, so now we are moving on to our products. Potassium bromide, which is another ionic bond. Now potassium has a charge of +1, bromide has a charge of -1, so those come together perfectly. 1-to-1 ratio, and aluminum sulfate. Now remember, aluminum has a charge of +3, sulfate has a charge of -2, so we'd be able to make this balance with 2 aluminums and 3 sulfates. There are our products, and now we've finished step 2. Now step 3, right out the equation as stated, basically means that we're not going to modify the quantities of any of these. So we're just going to start by writing that aluminum bromide reacts with, so plus potassium sulfate to produce, write an arrow for that, potassium bromide and aluminum sulfate. There's step 3 done. Now here's where the balancing happens. Step 4, identify the numbers of each element on each side. So here we have a single aluminum. We have 3 bromides. We have 2 potassiums. We have a single sulfur. And we have 4 oxygens. Moving over to the other side, we'll keep it there level, keep it consistent. We have 2 aluminums. We are down to just 1 bromide. We have 1 potassium. We are up to 3 sulfurs. And 4 times 3, we have 12 oxygens. There's step 4 done. Now step 5, identify the elements that are not balanced. So 1 aluminum, 2 aluminum is not balanced. 3 and 1 not balanced. 2 and 1 is not balanced. 1 and 3 not balanced. 4 and 12. None of these elements are currently balanced. So now we move to step 6, increase the number of molecules of certain elements that are not bonded. So for example, we can't take anything out of this equation because we have the bare minimum of just 1 of each molecule going in and out of this reaction. So what we can do is we can add additional molecules to this reaction. So for example, here we come out with 2 aluminums, we only go in with 1. So a simple solution could be to put in 2 aluminum bromides. Now what's really important is whenever you do this, that you adjust accordingly. So now we have 2 aluminums, and now we have 6 bromides. Now notice that we have 2 aluminums, so the aluminums have now been balanced. But now we've exacerbated the problem with the bromides. And this is a case where sometimes you'll need to go back. So because we have 6 bromides coming in, we must have 6 bromides coming out. It's a necessity. So we'll have 6 potassium bromides. We'll just that accordingly. Notice that also influences the potassiums. So now the bromides are balanced. But now we've just created another problem with potassium. Now there's too many potassiums. So 6 divided by 2 could give us 3. So a potential solution to this problem would be to have 3 potassium sulfates. And we'll immediately adjust the numbers accordingly. So everything multiplies by 3. So instead of 3 potassiums, we have 6. Instead of 1 sulfur, we have 3. And instead of 4 oxygens, we'll now have 12. Now this one worked out very well, where by doing that, we were able to balance out everything perfectly. There's now 6 potassiums on each side. There are 3 sulfurs on each side. And there are 12 oxygens. Now, if applicable, in step 7, you repeat steps 4 and 6, where we started with identifying the number of elements and updating them, identifying elements that were unbalanced, increasing the number of molecules, until the number of each element is equal in reactants and products. So we can double check that to make sure we have 2 elements going in, 2 coming out. We have 2 times 3 is 6 bromides going in, 6 bromides going out. We have 3 times 2 is 6 potassiums going in, 6 potassiums coming out. We have 3 times 1, 3 sulfurs going in, 3 sulfurs going out, and finally 3 times 4, 12 oxygens going in, 12 oxygens going out. So we have balanced this chemical equation.